Example 4 says solve the systems of equations by elimination if a solution exists. So again, even though it says elimination, if you find something is easier in substitution, use substitution, or if you just like substitution method more, use that. Now I have a note over here that this is the exact same problem as 2B, and that's what I said. So even though this instruction was to use substitution, we use substitution to solve. I would have used elimination here though. And so here's the exact same example. We're going to do the same problem by a different method, and hopefully we get to the solution of 2, 1. Okay, so when you use elimination method, the whole goal is to get one of your variables to eliminate. I'm not going to eliminate y's because of that 3 and that 4, but I can easily eliminate my x's. If I multiply this top one here by -2, let's see what happens. So I'm going to do -2 times x, -2 times 3y. And then when we use elimination, the most common mistake that happens is we forget to multiply this constant. So you are multiplying the entire equation, not just the variable. So we also need to do -2 times 5 to get -10. And then I'm not multiplying this bottom one by anything, so I'm just going to rewrite it. I do want these to be stacked on top of each other. Okay, so now let me kind of back up and explain what we just did. When I'm using elimination, I want them to be like this right here. We have -2x over a +2x. I want the same variable to have the same number but opposite, one positive and one negative. We said 2 videos ago, or maybe it was 3 videos ago, that elimination is also called the addition method. Because when I now add these two together, -2x plus 2x cancels out. That zeroes out right there. And now I have eliminated one of my variables. So now we will add what we have left here. So -6y plus 4y gives me -2y. -10 plus 8 gives me -2. And now I have a one-step equation here. Divide both sides by -2. And we get y equals 1. Once I get one of my variables, substitute it back in. It does not matter if you want to substitute it in the top equation or the bottom equation. You get the same result no matter what. So I'm going to take the top equation because it just simply looks simpler. And so I have x plus 3 times y, which is 1, equals 5. So we get x plus 3 equals 5. I'm going to squeeze this in here, subtract your 3, and we get x equals 2. Now my math lab just wants x equals y equals, but I like ordered pairs. So this is at the ordered pair 2, 1, which if I compare to example 2b, when we had the exact same problem, I got 2, 1. So that's why even though it says use substitution or use elimination, use whichever one is easier or whichever one you prefer, because you get the same result no matter what. And if you're taking my class on campus, I don't care which method you use either. I'm not going to tell you use substitution or use elimination. I'm going to say solve the systems of equations. Okay, now this one's a little bit more complicated because of those decimals. So this is one that 100% you're going to want to use elimination. Substitution gets really, really messy with this one. So last time I eliminated my x's, just because I know that I can multiply this 1x times a -2 to get those to cancel. Here, I don't really have that option of multiplying one equation, and I kind of take that back. We could probably multiply that 0.3 to get to a 5. No, I don't know. It's a little complicated with the decimals, right? So what we're going to do is because my y's here already have opposite signs. I have one positive and one negative. I'm going to cancel out my y's. For this one to cancel, all I'm going to do is swap my numbers here. So this 0.4y means I'm going to multiply this bottom one by 0.4. And this 3 right here means I'm going to multiply my top one by 3. I am just literally switching. So now distribute that 3 to all three terms, your x, your y, your constant. So 3 times 0.3x is 0.9x. 3 times 0.4y is plus 1.2y. And 3 times 2.4 is, I think, 7.2. Yeah, use your calculator if you need to. Okay, now do the same thing with this 0.4 to, again, all three terms, not just the x and the y, but also that constant. So 0.4 times 5x, that gives me 2x. 0.4 times negative 3y gives me a negative 1.2y. And 0.4 times 11 is 4.4. Okay, so now that I have multiplied, now I'm going to add. You notice we have a positive 1.2 and a negative 1.2. So we have just eliminated our y's and now add what is left. 0.9 plus 2 gives me 0.29x. 7.2 plus 4.4 gives me 11.6. Again, elimination is nice because once you get that one variable to eliminate, now we have a one-step equation. Let's divide both sides by 0.29 and we get 4. Okay, that's only half of my answer. I need to now get y. We can plug it into the top one or the bottom. However, I'm sure you've had enough with the decimals, so let's go into this bottom one here. So we have 5 times x, which is 4, minus 3y equals 11. So 20 minus 3y equals 11. So I'm running out of room again, so subtract your 20 over. 11 minus 20 gives me negative 9. And divide both sides by negative 3, and we get y equals 3. So we have ordered pair 4, 3, always x, y.